Okay, Professor Bear here. I was sent this little article by a student, and it has sort of interesting things. Not so much what they claim to talk about, which is context rot. What context rot basically means is more data isn't necessarily better. That is, they're going to use a needle in a haystack analogy, which we'll go over in a second. Before going on this, I'm mainly talking about this, not so much about this article, but the importance of clear thinking. So we won't talk about this graph a lot. Basically, what they're asking a probabilistic model, an LLM, to do is a deterministic task. And so we won't talk about this a lot. This is not the most important. It's just very confusing why this is even in the paper. So let's move on. We might talk about that at the end, but probably not. It's sort of a waste of time. So, but what's more important is here. So they're talking about this needle in the haystack problem. What that means is LLMs are very good at this. If we have a bunch of completely unrelated text around something and two things that are close lexical match, LLMs are great at finding that lexical match. This is called needle in a haystack because it's sort of a very different looking thing, a needle in a haystack. And the paper sort of implies that a lot of, big companies which talk about how big their context windows are is a little misleading because often the tests they use are geared towards doing well in a needle in a haystack problem. And that's an easy artificial thing to set up. Basically, you get two things which are very close and a bunch of stuff which is not at all close, and you'll do good on synthetic data like that. So they're going to test this idea here of, is this more context really good? I'm going to focus on sort of their thinking, and this is why I'm talking about this. And not so much about context rot, is about how to set up an experiment. So they talk about this needle in a haystack thing here. And so it's what they're just basically repeating what they had above. You have something that's really close and a bunch of stuff which is not so close. Now here things start getting weird. So they call this a distractor. So what was the best writing advice I got from a college classmate? They claim the right answer is the best writing advice I got from my college classmate was to write every week. And the wrong answer is I think the best writing tip I received from my college professor was to write every day. So it's kind of ironic that they're sort of implying that these big companies are setting up artificial tests, and they're setting up a test which is just as poor or poorer. At this point, we can ignore the rest of the article. If what I understand is true, that this is their test, matching this is right and matching this is wrong, I'll let you decide. Is this really a wrong answer to that? What was the best writing advice I got from my college classmate? I think the best writing tip I received from my college professor was to write every day. Seemed kind of good. This also seems kind of good. So from my perspective, if it picked these two needles out of this haystack, you're good to go. You're doing a good job. As far as I understand what they wrote, and it's a little sort of awkward writing in this thing, this is right and this is wrong. If that's true, and I think it's true from what I've seen, then we can basically ignore this article. They've not set up this experiment well. But let's go on and talk about it a little bit more. We can basically ignore everything after that if this is true. If it's true that this is the right answer and this is the wrong answer, just ignore the rest of the article. This is just not good work. So what they do here is they have a few little tests. And what this test is here, it's the needle similarity. What that means is if you have a question that's very similar to your needle, like, I'm looking for a needle and it says needle, but if you're saying I'm looking for a long, metal sharp thing that can sew, then it's not going to do as good. Still, it seems like their artificial data is poorly constructed because if you have just those two versions of a needle, but everything else is completely irrelevant, it's not even close to even the not close. Needle number 2 is still way closer than the rest of the haystack. You're going to get charts like these. So, I don't know what this says other than, think about how you create your synthetic experiments. So let's go on. And now they claim the more we add, is going to make things worse. And so here's their little needle, the best writing tip, and they have four responses here. Joe, pretty good. So here's the question, here's the needle, and these are all wrong answers. The question is, what is the best writing advice I got from a college classmate? The best writing tip I received from a college professor was to write every day. That's a wrong answer. The worst writing advice I got from a college classmate was to write each essay in 5 different styles. Even though it's in the frame worth writing advice, it's still writing advice. You may not believe in this writing advice, but it matches this question. This is all what the language models do, is they just match closest matches. This, I guess, is wrong because there's the context of high school in there, maybe. I don't know. But if we have a big, big haystack and everything else in the haystack is completely irrelevant, and it's getting these 5 needles out of a massive haystack, is that really wrong? I don't know. And so they go through a big, long argument of how massively this degrades when we have more options. But that's just sort of obvious. So going back to the needle and haystack analogy, hay looks very different from a needle. So if you have 5 things that look like needles, like one long metal pen and a needle and a broken needle, and it's picking those out rather than the hay, that's what these things do. And so that this is wrong. Their big sort of argument here, which isn't a bad argument, is that more context isn't necessarily better. So basically, this goes back to garbage in, garbage out. If you, for example, give it a lot of dirty hay, if you're looking for a needle and you put in a lot of real world data, which typically is dirty, and it has a bunch of broken needles and other things in it, which is just more likely to have with more data, you're likely to get it matching to these things that aren't really what you want. So that's sort of obvious and true. I'm not sure these experiments show anything other than how to not set up an experiment. And here's their probably only interesting graph in this little thing. What this is saying is that Claude, for example, let's say Claude finds 5 needles. It's more likely to say, I'm not certain which is the right needle. I found 5 needles, and I'm not certain which is the right needle. So here you go. I'm not certain, but I think maybe it's this or this or this or this, which is a pretty good response in my opinion. Where ChatGPT does not really do that. It'll just pick one of the needles and be very super confident about, okay, this is the needle. Even though there are 5 needles in there, you cannot see all those needles because that's what it does. It goes through the whole haystack and finds the 5 needles. ChatGPT is much more likely to give you a response. This is the needle, even though it found 5 needles and just picked the best needle and returned it to you. Where Claude is more likely to say, okay, I found 5 needles. I'm not sure which is the right needle, but here you go. And the other one, I forget what they used. They used, I think, Gemini and something else, Quen, and they were more in the middle. They're more, okay, sometimes it'll give you some ambiguity and sometimes it'll be certain. This is probably the only interesting, plot in their whole thing. And then they just keep on doing this. So this is where, what if your hay looks more like hay than a needle? Are you going to do worse? Well, of course you're going to do worse. And then they go into this thing at the end. I have no idea why they're doing this. Where they're using an exact test, a deterministic test. So here, what it is we're trying to get exact sequences here. See if they give an example. I think they do give an example of what this means. Basically, an exact sequence, and I think they gave an example here is San Francisco, and then one of them is different. And so if you're using like a Python program, this is a trivial task to print San Francisco 1,000,000 times. But language models aren't Python programs. They're probabilistic. And so the longer they are, the more likely they're going to say something different. And I have no idea why this is relevant at all to their argument. My argument is way back at the front here. And this is why I'm making this, is for students thinking about, because these are, professional data scientists working at some company, is back all the way up here. Where is it? It's, it just started here. This is their premise. Their premise is this is right and this is wrong. And I'll let you think about, is this right or this is wrong? Once they have that premise, everything is based on that premise. And, they're saying, what is the best writing advice? I got it from a college classmate. The best writing advice, this is the right answer and this is the wrong answer. So my main point isn't so much context throughout, which is important. They're right in the sense that more isn't better, but that goes just back to garbage in, garbage out. This is more about how do you set up an experiment. This is not how you set up an experiment. You think about it. As a human being, think about it. Just is this a wrong answer? If you as a human being do not think that's a wrong answer, then why do you expect a language model to do more than that? It makes no sense. So anyway, I've probably gone way longer than I want to on these things. I want to keep them short. So do the like, subscribe, ring the bell thing. This is just a response to a student question. Take care.